Hello and welcome back to another video. In this one we're going to explore the interaction with the Maiar Exchange through the erdpy. In this video we'll go ahead and interact with the testnet or devnet version of the exchange and use erdpy to interact with it. So I'll give a second here to fire up our machine. And what's ideal here is basically everything that we've come to interact with on the Maiar Exchange can be essentially converted into command line executable commands that sends it over to the blockchain to execute for us against whatever smart contract. Let's see. This will pretty much be ideal if there's any situation where maybe the web page, which is essentially the application wrapper surrounding or wrapped around the smart contract that's deployed on the blockchain there. So we'll fire up my handy dandy web browser and my Visual Studio Code. And I'm going to be following a runbook. I'll be attaching a link to this runbook up on in the description below. But we'll be closely following this with some alterations as we run through this here. See, so this example, we're going to use the testnet, and I'm going to have to use the devnet version of Maiar Exchange. Okay. I'm going to be pretty much walking you through starting these round of tests from scratch here. One of the references we will need is the Elrond Converters tool. And this is pretty handy dandy stuff. We'll be essentially using this to convert some of the jargon that we find when using the web wallet interacting with the Maiar Exchange. Yeah, so I think I got everything set, so we'll go ahead and begin and move on to creating a wallet. So we'll just do this here. Just to show we got erdpy configured. We do, I can tab. So we're going to create a wallet. Now there's a magnitude of ways we could do this. This was the example I used for this video. But we can essentially run this command. And it'll give us, auto-generate a 24 word seed phrase. Essentially I'm just doing a delimiter cut command, grep, or basically it's just running off of this here. So I'm pretty much piping this command and cutting it so that way you get rid of this mnemonic and we just get the remainder there. You can go so far as even creating your wallet here for it. So let's see. Okay. Alright. Alright, so I just kind of created a workspace here. So I made this in my test runs prior to making this video, so I got a pretty good grasp and understanding before I did this video here. So you can also create this command that essentially will print your 24 seed phrase and create a file of the pen file all ready to go. Because for this, signing a lot of the erdpy commands, the blockchain usually is easier to just use a pen file to pass in there. That way, you know, it's already connected to a wallet and transactions are faster and easier to process, paying for gas fees and signing off on transactions and whatnot. So we can go ahead and just run this command here again. Alright, so I'm gonna pretty much grab that there. I'm just gonna do this. Forgot to add the F. I'm gonna pipe that into this. So looks like we got everything created. So let's go ahead and open up a folder too while we're here. And you can see the M file I just created. Well, I guess it opens it up in another one. I can't open it up here. Very interesting anyway. Sorry, let me just take a minute here to get some things in order. There we go. It's on. Way harder than what's needed to be here. Okay. Alrighty, I think we're good. Alright, so we have our test wallet created. Next thing we're going to do is log into our wallet here. Pretty much grab some faucet money to play around with. Click on PEM, select the file. There's our test PEM, I think, that we created there for the YouTube demo. You can see we have no assets under here. So I'm just going to go to faucet. Okay, give it a moment to see the transactions appear right down here. And there we go. Excellent. So now that we got our faucet money to play around with, we can log into the Maiar Exchange. And this one, we're just going to go to the devnet. Connect using the Elrond web wallet. Select the PEM file. Same PEM file that we're doing here. Alright, let's take a look. Okay, it looks like everything's checking out. We have no assets. It's a clean account. Excellent. So now we're going to go ahead and do some tests here. What I'm going to try and demo for you first is try it out on the exchange, and you can see how the transactions process into Elrond code that's being sent on up to the Elrond blockchain. It usually appears in the data field of your wallet. So we can take that snippet of info, dissect it, and inject it into the erdpy command, which will essentially replicate the interaction as if we're on this website here. Instead of doing everything with the wEGLD, you just do it all straight out of your command line on your computer. So if this website ever goes down, in theory, since this web page is on a server just hosting the web page that's wrapped around the blockchain smart contract. The blockchain smart contract is residing on the blockchain, and that blockchain is supposed to have a pretty good SLA of what type of uptime it has versus its downtime. So there's less chance of the blockchain going down. Long story short, layman's is basically you can interact with the blockchain because it should be still up and running despite this web page going down. So if we're in an event where somebody decides to not pay the bills for the server and shuts us down, and you have all your assets tied up in a farm, you can go ahead and use the erdpy to execute commands to, at best, pull your assets out of the smart contract and convert them back into your native coin, which is EGLD. So in this example, what we're going to do is we're going to swap our native token, or native coin EGLD, to a tokenized version of it, wrapped EGLD. So you can see the two right here. So what we're going to do is replicate that by going into our account. You can see we have a wrap command, so we'll just do a test of wrapping one for now. Oops. Wrapping it. So now we executed an action, or a transaction. Select our PEM file we're using to test this out with, and you can see the data field right here. Usually the smart contract will be somewhere here. So we take notes of this, and as you can see, I've done that here too. It looks like in this one, they are using this smart contract call. So I'm going to copy that and update my notes here. The action's called wEGLD. And we'll go ahead and sign this. You'll see that the action's being done here. So we can go back to our wallet. You can see in our transaction history down here, you see that 28 got converted into the token there. You can click on the transaction to see the info we got. Okay, we see it made a call out to that smart contract, and it passed in these arguments, and it looked like it responded. So we're going to try and replicate this with erdpy. So let's give that a go. So we see that we've extracted these fields right here from here. And notice that there's these @ symbols, almost as a type of delimiter or separator. We can pretty much extract the hex value out of that. So the first one we got is this number. That's a hex value that actually, if you made it human readable, comes out to the NFT or SFT, semi-fungible token, non-fungible token, human readable name of it. So we got that there in this line of code. And we got this one, and this is the hex to decimal, and it came out with this equaling the 1 EGLD that I wanted to swap. And you see the 1 there, and the decimals, I think it has about 18 zeros after that. So let's go ahead and convert that and inject it into our erdpy command. I do have to update this smart contract call, so I'm just going to update that by doing that. And as this runbook isn't solid, it isn't static, it isn't, this one single source of truth. You may find there will be contract updates or updates to the environment, the devnet, testnet, or prod, or mainnet. So these contracts may change or alter. So, as you've been using your website, it's going to generate all these logs here, all these ledgers and interaction they have. So try and, do some reverse engineering and some detective work to figure out which smart contracts are the ones that you're interacting here. And you can kind of, piece it together and replicate it on erdpy. So let's go ahead and see if this command works. See ERD is making that the command. Just detail as the command executes. This gives us verbose output so we can see all the line items to pick it apart if anything were to go wrong. Here's the contract function or argument for erdpy. And we're calling, so you can kind of dissect this as we mentioned in our previous videos. So, -h, and see how the commands are ran. So you see the erdpy, contract, which is here. So we do another step up. And then you see all these options here. And so we have call, which is that one there. Alright, so that's what we're doing. And then now you can see additional information that we can see and use in order to interact with smart contracts or whatnot. You can take the time to review this, and you'll see that these are all these items that we're running across here. So let's go ahead and run this command, and just to kind of step through it. Smart contract, the function is wrapped EGLD. This matches this argument there. And you'll start to see a pattern as we run through this. This particular smart contract call accepts values, so that's the amount that we wanted to send. And the chain is what chain we're doing. We're doing devnet, which you can see right here and right here. And the path to our PEM file that we created. So I may need to update that as well. Setting the gas limit and the actual proxy on devnet, as well as setting the recall nonce and the send command. Let's go ahead and put that in. So you see it communicating. Okay, it looked like it went through. So now you see I got 2, and now I'm down to 27. Alright, we can review this command. Everything looks like we replicated it well. Excellent. So now let's try and play around in swapping that wrapped EGLD into MEX. So, again, as before, we'll go ahead and swap one of these EGLDs for MEX. We'll just do one for now. Now, here's one thing that I noticed. I guess the slippage in the exchange rate is always changing, and this is where it gets tricky. I'm sure that I remember seeing somewhere on their GitHub that they had some type of code that would do these calculations for us. So even though I'm writing this down as one of the steps right here, it may change in time, because the values that it gives us is at the time of the market. Wherever that exchange rate is these hex converted values. So the command that we're running through may change for you, which is why I recommend, if you have a chance to get on here, or you're able to pick apart that code that does this, add it to your process steps, awesome. Share it with the community. Even put a comment down below if you found out how to do that. But for now, just for time's sake, so this video is going to get long anyway, I'm going to start talking a lot, but I just use a quick sample interaction with the web page to kind of give us some of that information. Let's see here. So here's our sample. So I'm going to copy this down, and a lot of this information will be what you find here in the human readable format. So I'm just going to take note of this real quick. And the smart contract that we're calling. It looks like it may have not changed. Awesome. So I'll just sign and submit that. Okay, looks like it's running. Come over here to your web wallet. You can see in real-time graphics here. Okay, so we got one left. Looks like we're executing some command here. Alright, let's see, did it go? It says it completed. Now we got a response from the smart contract. So we should see it inside your folder. There it is. Alright. So now let's try and pick a part. That looks the same. Looks the same, that looks the same. Same, and oh look, these two numbers changed. So let's see. Originally, my previous example is this. So you can see when I use that conversion tool, it gave me the MEX token, smart contracts. This is the command of data, the number of wrapped eagle we're sending to it, and you can see all this right here. Swap in fixed input, so on and so forth. So what is this? I'm wondering though. It's different than that one. So this was in our example. Let's take a look. Okay. Real quick. It looks like it might be a string or an integer. Let's see. Convert hexadecimal to decimal. Let's see. It's probably the amount. It's probably the amount of MEX to convert it to. So that's probably the thing that changes since the exchange rate. Let's see, how much was this at the time? Yeah, so it's probably that. So let's see. Okay, go to my wallet. Doesn't look like it. So maybe I don't know. I don't know what this piece of data is. It's probably how much we sent at the time, and maybe there's maybe some padding that happens since the markets are usually volatile. So, but any cahoots, since this interaction is what's working, going to this version. And here's another thing too, if you check this out. Hopefully I don't talk long where that conversion rate expires, but you can also do a string version of the command, and you can pass in the arguments here, like you can state that it's a string and actually put in the token there, the amount, string and the actual action there, another string and the MEX token and the amount. So 0x is usually the hex version, and string is the human readable format. Let's try this out. Let's see if we can do the string version on this example. So this number is the amount of MEX that was different from this example. So I'm just going to swap that out. And let's test it out. Oh, we forgot to update that path. Alright, let's give this one a go. Alright, looks like we got something. Alright, well it took the one wrapped EGLD. And now we just wait and see if the smart contract likes it and can follow it by going there. Well, looked like it took. Excellent. But now we're completely out of wrapped eagle, so let's trade a couple of pairs. Let's grab some more. Here, let's see. Yeah, right. Let's grab this one. Let's just change this value right here. Instead of 1 EGLD for this command, whoops. Let's change it to 2. And there we are. Alright. Excellent. Let me just create another file here. Since I'm gonna have to be updating this a lot throughout this runbook because it's using the path of my previous test I did for this video. Alright, so let's take a look. We have now created, we swapped our wrapped eagle for Max. So next step is creating an LP. And this one becomes interesting because it's actually using, these commands are formatted in a weird way. Like, it's actually built into the platform, into the protocol itself. Some of the contract calls that you do is built in to the protocol. So when you're making the ERD call, contract call, you're not actually calling the smart contract address, you're calling your own address, because your own address is tying into this protocol wide, the whole entire Elrond environment. All wallets are tied in to the smart contract by default. So it's kind of weird. So I want you to take a look at that. Keep that in mind as we walk through this here. So here is the information about it. We can see that there's these constants that are just built into these functions that are just built in the whole platform. So you can see NFTs are a part of it, minting, burning, ESD transfers. So when you have time, take a look at this readmes and the documentation on the Elrond website. Kind of gives you a good rundown. So here was a test that I did, and it failed. And you can see that the call's coming from my wallet, and it was going to, which I thought was supposed to be the smart contract of the address, but really it was going from my wallet to my wallet. And I'll show you what I mean here with the successful transaction. And I thought, this looks very funny. Why would it do that? But lo and behold, it's a pretty much a constant throughout the Elrond platform protocol that this function exists. That adding liquidity, ESD transfers, and whatnot, you're just really sending the call back to your own wallet, and it just knows out there that you're interacting, doing token swaps. That's what I'm guessing. So let's go ahead and take a look and do that here. Looks like it disconnected me already. Alright, let's go to liquidity. Alright, we'll do an ESD to max transaction, and we're just going to do a half EGLD for now. Notice the numbers there. Let's kind of document this. Let's kind of we can see all this info there. We can also see that it's highlighted for certain sections here. Notice this double @ sign. So there's just no variable field in there. So you can kind of see the breakdown. So this is the wrapped EGLD right there. So we can take a look at that. Hexadecimal to string. Or better yet, there we are. And this is the amount, so that's going to be hex to decimal. There we are. So continue, next bit of info. That looks like the, right there looks like the max. After a while, you can kind of start to see the formatting, kind of just know what it is. And then this looks like the amount. Decimal. 363, 15.0, 15.0, 551, da da da. Yeah, looks good. So I'm just going to copy all of this. And notice that info there, so I'm just going to go that. Alrighty, so we got the transaction going. Let's see. Alright. Oh, yeah, I forgot to copy in what the, well, actually, I shouldn't need a smart contract, right? See, it's sending it to my own address. So if we take a look at the, yeah, so it looks like it already worked. Go to MetaSD tokens. Looks like it's not processed yet. Just take a look on the Explorer. Yeah, you see it, the from and to is my same wallet address, which sounds counterintuitive, but it is what it is. So, yeah. Alright, then we have our LP. So let's go ahead and dissect this code, and hopefully the ratios are the same here. But, let's give it a go. So, since we're calling our own wallet, update that. So we have the function call, which we saw there. Which was right there in the call, which I copied right here. Transfer, now we got some arguments. Okay, this is this is going to be the smart contract. So that looks like it didn't change. 2. That looks the same. Oh, and here's that double @ sign. So it's represented by a 0x is what I found out. I'm putting the hex version of that to make this double @ sign appear. Now this changed. So I'm going to copy that, paste it there. So now it's matching. That's matching another double 0, see? Or double @ there. Okay, so did this number change? So I think that number changed right here. That's the same. That looks like that needed to change right here. And that needs to change the amount there. Alright, let's go ahead and send this transaction through. Alright. So we got some errors here, so let's investigate. Why did this not like? Invalid receiver. Oh, see? Alright, so I got something along here is the wrong one, so I bet you it is this address, maybe? No, that's the same. Yeah, I guess I didn't update that one correctly. Let's see. Let's compare our working example. Yeah, so that's that address and the same, and that one and that one. So 06C, huh? Yeah, this must be wrong. So I'm just gonna, guess it didn't copy or something. Well, let's see if this one works. Alright. Failed yet again. From 06C. So I wonder if one of these addresses here is wrong. So in this one I know it's probably going to be hex 2 ERD wallet. That's the smart contract. So what I'm probably going to do is something like this. Let's see if this works. So this is the hexadecimal version of the wallet public address. So maybe I was using the smart contract still, so let's take a look. Nope, still didn't like it. You know what? I think this is it. Add liquidity is what I got wrong. So maybe I have to try do that. Right? Let's see. Multi-NFT transfer. Multi-NFT transfer. Yeah, I'm sending that info over. Good old troubleshooting here. So we'll just do this step by step again. 2. That one's the same. There's a 0. Okay. Yep. There's 0. That matches. That matches. That matches. And that matches. Unless... Let's just use this as the working example. So, as you can see, this is what gave me some issues here. Okay, so, from address is ourselves, and it's going back to ourselves. But for some reason, in this command, it's saying that the sender, the receiver, is not the same. $3DY, T3D. Maybe the smart contract is different. But all that info was the same. I thought that this... Alright, well... Guess we shall see here. Did not capture it? What's going on there? Oh. Did not hit enter? Yep, fourth one is a failure too. Something is weird here. Hmm, that's interesting. You know what? It's because I'm using a different pen file. Whew, long day. Alright, so here we go. All of that looks good. Gotta remember this pen file. Okay, now let's try it. Oh, we got more, and it took out 5, and it took out those 3. I guess the slippage exchange rate didn't change much in that time wasted, but let's just see what happens here. This number should change too. Take a look at the transaction here on the Explorer. Maybe wallets are matching this time, so that looks good. Okay. Let's just see if we can refresh that. Yeah, there we go. Excellent. All right. So now we can go ahead and stake the LP here. So let's try go back into, so we have our liquidity that we just added, the LP. So, you know, when you usually click stake, it takes you to farms. And usually it takes you right down here. It usually asks you to, you know, stake, right? So let's do 5, no, 0.5 for now as a test. Stake. And we'll notice the info right here. So we'll copy that. give this smart contract call. And the rest of the info there. 60, 60. Oh, I forgot to grab the smart contract address on that. Can just take a look here. Transaction from here to smart contract. So I copied that, and there it is. So we have the NS, that's the function, so that goes there in the command. Then that is the smart contract, so that looks good. Entering 1, that looks good. 445, which is the hex version of that. It's entered. You can see the EGLD next token. There's a 0 after that. There's a 0. And then amounts. These are different. So I'm going to switch this right here. And this is a different amount there too. Okay. So let's see, gotta change my pen file. Alright, let's see where this takes us. Oh, gotta grab my wallet address too. And you can see that we're down here. There we are. So that should all be matching. Let's send it off. Let's see what we got. So this should be taken out and just remain 259 afterwards. We'll see what happens. There it is. Processing. Fingers crossed. Going through our mix farms. This was the example that we did before. Alright. So let's see, it looked like this responded, right? There we are. Now let's take a look at this real quick. So even though we entered the same command for this, this was a very interesting finding. But you'll notice that it's entered into two separate pools. We don't want that. We want to input it into the same pool so that way you don't have it separated, and we want it to look nice and collected in one central location. So let's go ahead and try another transaction and try to put it into the same pool there. So basically we'll need to grab some more EGLD. Let's go ahead and give ourselves maybe 5 this time. So I'll let that command run. Okay, excellent. Oh, didn't like that. Wonder why. Guess I was calling a different contract. Let's take a look. Alright. Swap EGLD to wrapped EGLD. Right there. I did make a change there. There we are. And just to save time, let's just do this. Plus 3. Don't give it 2. Alrighty. So now we can try and run the command to stake it into the same LP. So we're going to go ahead and do that. There we are. Let's see. And I'm just kind of, whoops, doing this all through here so we can get to the example a lot quicker. Since we kind of already went through the ERD commands, the ERD version of what we're doing here. So I'm just going to create some more LPs to work on this example. Excellent. So when we enter the stake pool here, right, we want to input just, we want to enter it into the same pool. We don't want it to be itemized like that. So we'll grab this sample text here. Send it through. And while that runs, let's dissect this. So we have the function there, and let's compare that to the other command that we run. So that's true. See, stake LP works, but it's in a separate NFT. So that command's still the same. Okay, let's take a look at the other arguments. Smart contract. Okay, smart contract's the same. Same. We have a 2 there. And notice that this one doesn't have a 2, it has a 1. So, yeah, see? So that's what I noticed changed there. So let's move on. This number looks the same. Looks the same up here in that command. 00. And this number. So, so you have 0, that number's changing because I actually put in a different number. Okay. That looks to be different as well. $25. It's not also there too. So you're starting to see there's a difference to when we add this command from the initial after that, there's these added variables that we see that's a little bit different. So that number's different. Nope, that one's the same. It's probably the ERD token name and the value. Alright, so let's update this command and stake it to the same LP. So you can see it added to the same one. So we're targeting to add it to the same LP pool here. And we'll just let that one go. Alright, so that's the same 2 this time. So 2's there, excellent. That's the same, we have a 0, 0. This is the same, okay, that's the same. This number's different. That's different. And that's different. Fantastic. Okay. Let's change the path here to... Let's run it. Okay. So this one's right there. Oh, we have a transaction failed. What happened? Let's take a look. So using that same PEM file again. Yep, that's it. Oh, now the wallet address there needs to change too. There we are. Let's give it another go round. Nope, doesn't like that one either. What are we doing wrong? There to that number. It should be good. UNFT data on sender for token this. Let's see. Wonder maybe there's a discrepancy now? Already in the time that I've done it? I do have one. Let's see, stake one. Stake. I'm not going to follow through with this. I'm just going to extract the data here, see if it's the same, and compare it. Copy. Cancel. Okay. That's the same. 2, 4, D, 4, 5, 25. It's not 25. That one was a 26. Interesting. So, let's try that one was a 26 before. Oh boy. Well, it was 26, so let's try that. Okay, well, I like that one. Took the one out of there. So now, if we refresh that, okay. Interesting. I'm wondering if it's because one was executed on the exchange and one was executed on the erdpy, if that made a difference. But let's take a look. Oh, it added it to the other one rather than the same one, but interesting nonetheless. Excellent. So we pretty much went all the way through and converting our native coin to a token, ESD, the ESDT version of eGold, wrapped eGold. Converted some of that wrapped eGold into another token, a MEX token. Created an LP and staked the LP. So now we're going to work backwards and we're going to unstake and remove the LPs there. So from here you can click on withdrawal, you can say max. And for this example, let's just extract the info here. Collect that. I'm just kind of showing you how to, that information that's being displayed when it's asking you to sign off on it is actually the information that you're using to pretty much replicate it in erdpy, so it does serve a function. So let's take a look at our example. See that address. I'm just gonna put that there as well. Okay. I wonder why that's double entered. Okay, arguments. This one, that one, that one, that one. Just go after that one. Looks good. Let's see if this works here. Okay, we got a wrong one again. Okay, looks like a wallet issue yet again. Apologize for not updating the path to the wallet here prior to this video. Okay, we failed it again. What was it this time? Valid argument spelled into the function, not a valid destination address. Okay. Maybe was it the contract? So we have a smart contract there. Let's see. Seven five seven sub. 757 sub. Huh, I didn't put that in there? Guess not. Let's see if that one will go. Whoops. Hmm. Let's see if we have to use this one. Test Japan YouTube demo. Interesting. Well, let's take a look and see an actual example and see what it looks like when we process it. Okay. Now's the number that probably changed. Smart contract address, and that. Let's take a look. So that took nicely. No, that is 28. That's so weird. Hmm. See, so I know that's the decimal, so that's probably 5, right? So if I just want to do a whole one, this should be it. Okay. And where did it send it to? Let's take a look at a successful transaction. See, it sends it back to me. I send it back to me. Invalid arguments to process built-in function. Not a valid destination. exit farm. Let's see, hex to string. Hmm. Yeah, that's being passed. I'm passing that. Let's try my address, I guess. See if this one works. That just blows my mind. I don't know. I mean, it's the same exact thing, right? We're passing in the same parameters here, right? Exit. Hmm. Hmm. Let us try and change. You know what? That's probably what it was. The method is the functions. Let's see. Did it go? Oh, there it is. There it is. He removed it from the farm. Excellent. Excellent. Okay. Alright, let's try these ones. Let's see. There it is. It's gone. So let's just do the max 1.5. Let's see what's different here. That's a 27 there. Looks different. So let's try and replicate that. That's the same. 27 is going to be different. That's going to be different. Whoops. The value. That's the same. That's the same. So let's try and run this one. So I'm wondering if these are some type of indicator of when pulling out, it knows to pull out from the same pool. And if that number, when putting in, those numbers change too, because it was 25, 26, now it's 27, and I think the other one was 29, 28, 27, 28. Yeah, that makes sense. 26, 27, yeah, 25, 26, 27. Let's see. 2, so okay, yeah, so that one, staked it. 28, about 28. Enter farm. Yeah, some type of numbering system going on, but I bet that's what the identifier is. Alright, so it looks like we pulled out of all our farms, so we shouldn't have anything there. Good, and if we go here, that should display nothing too. Alright, excellent. So now we'll move backwards and we'll remove the liquidity pair here. So we'll just kind of walk backwards, grab the info, and replicate that in the erdpy. So now that we kind of get a gist of things, we don't need to do a working, hopefully you don't need to do a working example. Just take this code and know what to input. Alright. So I tried removing before the timer runs out, and you know, when it was still at that penalty. So it for the most part didn't look like the code changed too much, but I wouldn't think you would want to pull out during that lock period, the penalty period. So, but when I took it out prematurely, I didn't see anything change in the data code. But again, just try some samples, extract the data, and that way, going through this video, you can kind of start seeing the pattern here of how I'm extracting the transmitted data, transaction data into erdpy. So, let's see. There, looks the same. So, let's see. Smart contract address, is it the same? Looks to be the same, so we'll just, yep, okay. So, smart contract looks to be the same. Argument's good. That looks to be different. That looks to be the same. Transmitting remove liquidity. How much is different though? And this bit of info. There we are. So we see that disappear, and we should see these numbers go up for mix and there. Okay, SD transfer. Did not go. It's really odd. It's not doing it. Let's see. Okay, got that. Is right. Function is ESD transfer. Yeah. Let's see. Transfer. Right. That number looks good. That number looks good. That number looks good. And that number looks good. Contract call. And it looks like we're using the same video demo there. My other wallet's going to get all these, the previous wallet that I used before this demo is going to get all these transactions. We're wondering why. So actually what I'm going to do is look for every instance of this and replace it with, whoops, that. Let's make the changes now. Okay. Processing. Alrighty. So it got processed. So now those numbers should change. these right here, so that looks good. So let's see, let's swap Mex back into EGLD. So let's go down to our executable command, go to swap. Okay, and just max that out, get that. Extract the data. Put that there. ESC transfer the same. Okay. Same. Instead of using this, let's use the one down here. The other one was a string version, so let's see transfer. Let's see, let's do this one. That's the same. That's different. And that's different. Fingers crossed. Alright. Excellent. Now let's swap this back into to the native token there. So obviously, there's commands that you can run to check to see how much the actual total is of this, since this rounds it up. But, you know, instead of running the command to see the value in our wallets, I'm just going to extract it from here. And that's the code I'm looking for. See all that? Okay. So, let's take a look. There it is. ESD transfer, same. That's the same. That's different. Now, when I ran this command prior, I thought you put in a value, right? But it was actually incorrect. It gave me an error and it didn't work. So it actually, the argument has to equal the value that we're trying to pass through. It's kind of confusing for sometimes, like certain things, has to use this as a value, and other times you have to know the arguments and what to pass into the smart contract. And I asked the community and the development team of Elrond, like, hey, is there a way you could dump or, take a look at what the arguments are that we need to pass through on a smart contract? And they said, no, there's no query we can run or some type of dump, or, we can't concatenate it or make it display the arguments that smart contract takes. Basically, in order to find out what arguments needs to be passed is to review the GitHub open source code of the smart contract to see where those fields are at and what type of variable or what type of value needs to be sent to it. Is it a string? Is it a decimal number? Things like that. A big number. The only other way I could think that maybe we could kind of sneak and peek is maybe setting up something like Burp Suite or some type of reverse proxy where we can actually catch the request headers coming in and out as it's interacting with the blockchain. If, granted, it's not encrypted, but who knows? At this point, maybe somebody out there can chime in and provide us some clarity on that, how to find that out. They're making it a lot easier, that's for sure. Instead of having to guess and looking at all these, examples off the exchange, you can just look at the smart contract, see how it's deployed, know what arguments to pass in. So, we just did the last step. We should get this 8 coming back into here. So it definitely took our tokens. And there we are. Let's take a look. There it is. So one thing I must let you know, and that's why there's a beauty of the devnet, is we can fine-tune a lot of these trial and errors here, right? All these failures, right? Because every time, even though it fails, you are still paying for a gas transaction fee. So you're paying to send this up there and try to interact with it. So every failure, it is chipping away at your gas fees. So that's why it's really nice that Elrond has probably one of the best dev and testnet environments, lower environments to interact with that I've seen so far. Their faucet's just absolutely amazing. It gives us enough to really go all out and do as much regression testing and validation as possible before deploying it actually into production or their mainnet. You try to do that on Ethereum, faucets are slim to none. If you do find one, it gives you like 0.3, and that's not enough to develop on, in my opinion. And so far, Elrond has an amazing environment. I like it so far. So, that's all I have to say about that. But yeah, so basically we pretty much went through everything that you would do on interacting with the Elrond Maiar Exchange site here. And did it and replicated it over on erdpy. So granted that if the site ever goes down, you do have some method to kind of test and interact and try to still interact with the smart contracts even though the web wrapper, the web page, this interface right here is down. As you notice, the numbers could change during, the market volatility and, the the slippage that may occur. Open to anybody out there that may know a workaround or an ERD command to kind of get that. But the main important things though is maybe wrapping the ERD tokens and maybe removing, because if the site goes down, maybe you're already entered in a pool, and let's say worst case scenario, the development team is no longer building on this and they abandon the project and you have all your funds up there, so you might as well go ahead and use this method to pull it out or what have you. So I just want to make this video to kind of strengthen and empower the users. I feel there's not a lot of content out there that actually describes this, even for the Ethereum for that matter, to how to interact with these smart contracts like this. It kind of walks it through like that, but definitely for Elrond. And once you're empowered with this knowledge, I think that adoption and a lot of other users can see the potential of this and use this to their advantage. So with that, I'll go ahead and bid you adieu. So I thank you for watching, sticking through all my errors and trials here. I think it was a good use case to show you that I'm doing this live on the fly with you sometimes. It's kind of good to have errors to walk through so you can see how I troubleshoot. Maybe it helps you troubleshoot and piece things together and kind of step through it, right? Using the converters here to see what is being asked, or you can kind of piece together what data sets are what. Using the wallet to see the transactions come through in real time, as well as the Explorer to see how your transactions were failed or, if they went through. In the next video, I'm kind of thinking of maybe exploring a little bit more into the DApp space and making, taking a look again, revisiting what the pilot video went through. I was watching some of Bogdan's videos. Bogdan went through a lot, and he made some good points and areas to look out for as far as how React.js and React, Rust, and everything like that works as far as the Elrond's template for the DApp is, the actual web interface, kind of like how Maiar is built, the wrapper around the smart contracts. And kind of seeing how these things interact. I think I made some breakthroughs. I think it definitely deals with a lot of ERD.js, but explore that. I was also thinking about maybe holding up some type of open sessions, doing a live chat on here, on this channel, inviting some of the community and viewers on here, kind of go through and maybe work together. I definitely don't know all the right answers or anything, but maybe we can help each other and discuss in an open forum, share ideas, some of our findings, and, help this project grow. I do see a lot of potential here, and I've been liking what Elrond has been delivering so far, and it's just sad that the transparency and the marketing and the attention that this project should be getting is not there, the awareness of it, so I would like to expand on that. So I think it falls on us, the community, to sometimes step in and kind of help out with that. But yes, please like, subscribe if you haven't already. Hit the notification bell so that way a new video gets uploaded, you're aware. And once we start to get into more, a repeatable routine here, I'll definitely start setting up maybe like a Discord channel and maybe some type of forum where we can know when we can schedule these live chats. I do have, my life and my job that I need to concentrate on that brings the money in, but hopefully this project will liberate us from the dependency of working and money and choosing to want to work, the need to work to survive. And that way I can focus on concentrating on videos like this and helping the community out. But yeah, thanks again everyone, and I'll talk to you all soon. See ya.